Deep HS HDR video, deep high-speed high dynamic range video reconstruction. We aim at generating high FPS high dynamic range videos from alternating exposure low FPS low dynamic range videos. Previous methods in HDR video reconstruction rely on flow-based image registration and alignment for motion compensation between input frames. Due to inaccuracies in flow-based methods, these methods have been unable to effectively account for alignment artifacts, thus resulting in motion blur and noise in challenging situations. Also, due to the lack of publicly available high FPS HDR video datasets, the problem of high FPS HDR video reconstruction remains completely unexplored. To overcome this, we propose the first deep learning framework for high FPS HDR video generation using video frame interpolation. Given an alternating exposure LDR input, we first interpolate between two consecutive similarly exposed frames to generate an LDR frame at the intermediate time step. We use depth-aware video frame interpolation, also known as DAIN, proposed by Bao et al. 2019 for generating intermediate frames. In this case, using high exposure frames at t is equal to 1 and t is equal to 3, we generate a high exposure frame at t is equal to 2. We merge this with the existing low exposure frame at t is equal to 2 using an attention-based HDR merge network to generate the final SDR image at t is equal to 2. Similarly, to generate the HDR frame at t is equal to 3, we first interpolate between low exposure frames at t is equal to 2 and t is equal to 4 to generate a low exposure frame at t is equal to 3. We then merge this with the existing high exposure frame at t is equal to 3 to get the final HDR frame. Using this approach, we generate HDR frames along the full length of the input sequence to get the final HDR video. During inference, we extend this approach to recursively interpolate among generated HDR frames and therefore increase video frame rate manifold. The proposed network is able to leverage the inherent temporal coherency of input videos even from low FPS HDR datasets. This allows us to generate high FPS HDR videos from low FPS LDR videos. We now present our results and comparisons against existing methods.